Thank you everyone for joining us today. Super excited to have you learn from our very own Tim Gremore at Headway. So today we're going to talk about Elixir for JavaScript developers, kind of how you can compare the concepts of Elixir and JavaScript. And so you can kind of get a better grasp of how you can get started with Elixir if you have experience with JavaScript. Just before we get started today, I just want to walk through a couple things. This presentation will be recorded and available on our YouTube channel afterwards. If you haven't subscribed, be sure to do that. And we appreciate any likes or comments and all that kind of stuff. Happy to help answer any questions along the way and in the comments. But also, if you're on the live stream right now and you have a question, be sure to submit it in the panel there, and we'll do our best to answer it for you right here on the live stream. And if you have any personal questions about maybe an opportunity at Headway, we are hiring, or any questions about Elixir and JavaScript, you can send us an email at ahoy@headway.io, and we'll do our best to get you the help you need to reach your goals. So that's about it for what to expect for today. I'm just going to jump into one more thing before I hand it off to Tim. All right, so this event is hosted by Headway. This is the Headway YouTube channel. We launch and grow new digital products with less risk, and we do that through business and product strategy, design, and software development. And we like to work with startups or founders that are looking to launch a brand new product. So we take their idea, we help them validate it, we help validate a possible software solution, and we help them get it to market through design and development and strategy. We also work with corporations that want to innovate, and so maybe it's improving an internal process or creating a whole new product to create a whole new revenue stream for their business. We help them figure that out as well and launch new products. So that's it for me. I think I can hand it over to Tim, and he can get started.
Yeah, welcome everybody. Thanks, Jacob. So as Jacob said, I'm one of the developers at Headway. I've been with Headway for what's going to be 5 years this fall. I've been doing full stack development with Headway, first as a Ruby on Rails developer. I've had a chance to work with some React Native, React for the web, and Elixir. And Elixir is my personal favorite, as anybody at Headway will tell you. So this is exciting for me to be able to talk with you all about some of those comparisons between JavaScript and Elixir. So we're going to stay fairly high level. We're going to stay fairly basic as we work through a series of foundational elements of each language, compare and contrast those foundational elements. We're going to talk about control flow. We're going to talk about some various list operations. And hopefully, if you are a JavaScript developer who has been interested in Elixir, this will be a helpful primer to you as you try to transfer your knowledge into a new language. So yeah, please post questions in the chat along the way. I will be more than happy to pause through the presentation and address those questions. We'll also have a time for Q&A after we present. So any question is a good question. Any time is a fine time, and we'll do our best. I'll do my best to keep you informed. What we're going to walk through today is, I'm going to be showing you something local on my machine, but this is an application that has been deployed. Jacob will be sharing the address with you in chat. This application it's going to walk you through, again, some of those foundational elements, different control flows, different list operations. It's simply going to compare and contrast JavaScript and Elixir, and you'll be able to reference that application, long after our presentation wraps up today. So, so without further ado, let's take a look at Elixir for a JS dev. Let's see, Jacob, do I need to? There we go. Okay. So as I mentioned, there's sort of 3 categories that we're going to look at, 3 groupings. There are plenty more, but as I said, we're going to try to focus on foundational elements across these 3 categories. And we're going to start with what everybody wants to know, and that's conventions. How do people go about, how does the community go about writing JavaScript that's consistent, that's readable, that's maintainable? And if you're a JavaScript developer, you've seen this, you use it, you're familiar with it. If you're not an Elixir developer yet, but again, you're interested, this is the compare and contrast between the two. So JavaScript largely has adopted camel casing for how we name variables, functions, how we name things in a JavaScript application. Camel casing would be lowercase start and then word breaks. Start with a capital letter, again followed by lowercase remaining characters of that word. So welcome statement, capital W, or rather lowercase w, capital S. Elixir, the convention is to use snake casing. So snake casing is all lowercase, words separated with an underscore. And that applies both to a variable that you would declare, an attribute, or a function name. So in this case, we've got welcome statement as a variable and welcome statement as a function, each being assigned the same value. Now there are more conventions, but again, we just want to stay at a very basic level. Okay, so you've seen assignment happening. Let's take a look and talk more specifically about how variables are declared. In JavaScript, you're likely familiar with what it is to declare a JavaScript variable. You can use const, let, var. Some of these are have intention. They don't necessarily have constraint in the language. So constant, you're saying foo is going to be 1 and it's always going to be 1 through the life of that variable within that scope. Let, here we're saying bar is 2 initially, but I might reassign bar to a different value further down in the scope of my application. And var is really what JavaScript at its core is using. So constant let is helping us communicate meaning and intent and ultimately write better code. But var is what we end up with. Additionally, if you've got a constant, so const, not to be confused with what a constant would be in this use case, foo is something that I want to be able to use across modules, across pieces of my application. So I might export const foo as a constant. At least that's the intention, that's the convention. And because it's a constant, we communicate that intention through fully uppercased variable name. So in this case, I'd export const foo from a module, and then I'd be able to import and reference that constant in other pieces of my application. So let's compare variable declaration from JavaScript to what we get in Elixir. So we'll see foo equal to 1. Notice that there's no prefix to this declaration. There's no type of variable declaration. Now there are type specs in Elixir, but that's a little bit deeper than we want to go today. So just notice that there's no const, let, or var. It's simply foo equals 1. Additionally, there's different types, and we're only calling out a couple throughout this presentation. One of the additional types that you won't find in JavaScript is something like an atom. If you're familiar with Ruby, a symbol, Elixir has an atom, and an atom is the name of the atom, the name of the variable, in this case, OK, or error. That's also its value. And so it's a very, very descriptive way and an efficient way to declare and assign value within your application. Okay, so we've got a variable named foo equal to 1. We've got an OK and an error atom. This next piece here is showing us how we would declare module attribute. So first, we've got the declaration of a new module named my super special project. And that module has a module attribute named foo with a value of 1. So if we went back up to JavaScript and we saw that we exported a constant named foo, all uppercase foo, with a value of 1, we can reuse that. Similar with a module attribute in Elixir, I can declare a module attribute named foo with a value of 1. There's an additional capability that Elixir gives you because it's compiled. So when your application is compiled, the value that you would assign to a module attribute is there's a snapshot of that value in time. So when it compiles, you're going to get the value of the module attribute, the value of your assignment at compile time. So it's best illustrated by thinking about the clock. If I declare a module attribute named foo, and I want to assign now the current timestamp to that module attribute, datetime.utc now, that value is always going to be the moment it's processed during compilation. It's not going to change at runtime. That would be different than if I assigned date.now in JavaScript. That value would always be now, not only when you've written and built your product. Okay, so just one caveat. It just introduces new possibilities when you have that layer of that compilation time concern. Sometimes it can be a gotcha. Other times, if you're aware of it, it's actually a help because you're able to do some unique things with that. Okay, let's keep moving to comparison operators. So in JavaScript, we can't write something like hi as a string assigned to hi as a string. We're going to be throwing an exception in that hi can't be reassigned to hi. Okay, now we can do, we're talking about comparison, so I illustrate this assignment attempt simply to contrast what we'll get to in the Elixir equivalent of that. Now, JavaScript does have double equals and triple equals. So double equals is a little bit of a looser comparison, as you're likely familiar with. So hi as a string equals hi as a string. That's true. Hi as a string triple equals hi as a string. That is even more true because it's comparing the type, not just the value. And so we don't have a triple equals in Elixir, but we do have what's known as the match operator. Okay, so the first example here of hi equal to hi, that's acceptable in Elixir because it's not assignment, it's actually binding, and there's a match. The equal sign is called the match operator. And what happens is you won't be able to bind the right-hand side of a match operator to the left-hand side if they're not equal, if there's not if they're not comparable. So this statement is true, hi equals hi. It is not, you cannot do that in JavaScript, it'll throw an error. This statement is fine, hi equals hi. Hello equals hi is not, that fails because the values don't match. So the match operator gives us a much deeper, much deeper concern, much deeper capability. It empowers so much more throughout the Elixir ecosystem than a simple assignment would do as maybe found in JavaScript and in other languages. Okay, but we're talking about comparison. So the match operator, that's one thing. There's also just basic comparison. So I can compare, does the string hi equal the string hi? Yes, it does. Does the string hello equal the string hi? It does not, it is false. So there's a fine distinction there. Just suffice to say that the match operator is not quite the same as assignment in JavaScript. There's quite a bit more capability that comes with the match operator. We do still have comparison as we would be familiar in JavaScript without a triple equals, though. Simply a double equals will get you the same level of comparison. Okay, let's keep moving. We're going to look at importing. So we've got resources in our JavaScript application that we want to reuse throughout. We want to write a module or use an external library that provides us with functionality that we need currently in our code that we're writing. So we're going to import. There's different ways to export and import. In this case, these examples, we're saying import React, which is a default export, and also import useState, which is a named export from the React library. If I have a naming collision, for example, I want to import React, again, which is a default export from React. but in the scope of my module, I want it to be named my React. Again, maybe you have a naming collision, maybe there's some expressiveness that you want to add to your code by giving it a custom name. These are a couple very quick ways to just to illustrate that. This is how we would import an external resource into a current module. In Elixir, we've got a couple more options, just a couple that we're going to highlight. When I import something into a current module in Elixir, I'm actually importing the functions, the definitions in that module, and I'm mixing them into my current module. So in JavaScript, I would use, in import React, I would use React dot my function name that I want to use. In Elixir, I simply have those functions available to me without having to prefix the function name with the module it came from. So if I import my super special project.helper module, any function on helper module is going to be available to me for use directly without having to prefix it with the fully qualified name. Now, if I keep moving down, we can also see how there's the concept of an alias. Alias would be similar to the naming, a custom name import in JavaScript as illustrated above, where we import React as my React. It's convenience. If I want to alias something, I can alias helper module, giving me shorter hand reference throughout the scope of my module by aliasing my super special project.helper module. So this would provide me with helper module dot instead of the fully qualified version. And I can also customize the name of that alias, which I haven't illustrated here, but that would be available to me. And then finally, if I want to import only certain functions from helper module, I can specify them. I can whitelist them with only as a list of only as a list of function names and arity. Okay, so let's take a look at functions in JavaScript and how they compare to Elixir. So we've got just a couple basic examples here. Add two numbers and return the sum of them. JavaScript, likely familiar with these two versions. I can use add. I can pass add around my application. The reference to that is available for me to use in the scope of where they're declared, and then also outside that scope if I happen to export and import them. Similar can be said about Elixir. So we declare a function in Elixir starting with def, definition, and then open up the body of that function with do, and then we explicitly end with the word end. Compare and contrast with curlies as found in JavaScript. The name of that function, add, takes two parameters, n1 and 2, and you notice that there's no return statement. There's not an explicit return in Elixir. So in this case, n1 plus n2 is what gets returned. JavaScript, you would call return explicitly unless you're using the convenience of an arrow function, a one-lined arrow function. Okay, so that's one way, def add, do, and +1 and +2. There's also the ability to bind a function definition to a variable named add, and you can see here there's two examples. Fn is a stubby function, different syntax, but accomplishes the same thing, where fn, a, and b as the arguments. The function body is opened up with a stubby arrow, a dash followed by greater than sign. A plus b, again, it's returned. There's no explicit return statement needed, and then end to end of that function definition. All three of these, def add, function a, b, and then the ampersand, which is called the capture operator, all three of these are going to accomplish the same thing. And then one additional piece worth calling out is that you do have private and public definitions in Elixir, which you don't have in JavaScript. There's conventions for it, but they're not strictly enforced like they would be in Elixir. And
oh, Tim just wanted to, we have a question that came in asking, what did you mean by arity?
Yep, it looks like Josh Downs, thanks for responding, and that's right. Arity is a general term. You see it much more frequently in Elixir because it's built into function definitions. It's used as part of the documentation, really. You're going to reference a function including its arity instead of, it's just different than JavaScript, where JavaScript has arity too. You would declare a function that may have 0, 1, 2, 3 parameters that it expects. That's the arity, the number of parameters that it expects. Elixir, it's called out. It's, you would say, my module dot private add 2. That's how you would describe a function name in Elixir. So that it's a little bit more descriptive. It tells you exactly what the function signature is.
Awesome. Thanks, Josh. Thanks, Brent, and thanks, Tim, too, for wrapping that up as well.
Yeah, that's great. Yeah, keep the questions coming. That's a good question. Okay, let's take a look at method chaining. And in JavaScript, we can see in this example, we've got people, which is an array of objects. Each object has name and age attribute on it. And what we're going to do is we want to filter out from that array objects that have an age greater than 21, and then we want to map over the result of that filtered array and only extract the name. And so what we end up with after calling people.filter.map is an array of strings with value Bob, because Bob is the only one over 21. So that method chaining is, you're not limited to that. We could add on to map additional function calls that an array would provide us. And in Elixir, what that looks like is it's a little bit different. We're not dealing with objects per se, we're just dealing with functions. So we're passing the return of one function into the start of another function. And that's accomplished with what is known as the pipe operator. So so we're going to start out with, again, a list, in this case, list instead of array, list of maps, again, with name and age as the attributes. And using the enum filter to function, we're going to filter out those objects that have an age value which is greater than 21. And then we're going to pipe that into enum.map, where we will only want to get out the name value, or the value of the name attribute, leaving us with Bob as one element in a list. So so again, we don't have dot syntax to trigger the next function in a chain of events that we want. We have what's known as the pipe operator, the pipe with greater than symbol. And so that example is a common one where we have a list or an array in JavaScript of objects, and we want to transform that collection into some other value, or we want to extract a specific element of that list. We can do that. We can use the pipe operator for quite a bit more than just a list, though. We can take something as simple as a number, in this case 45, and we can end up creating a function, a mathematical equation, using, in this case, the division function, which comes from the kernel module. We can use on math. So this colon math is calling an Erlang function, and then we also have kernel dot asterisk in order to multiply. Again, the result of that series of pipes is essentially this this algebraic equation at the bottom. So, okay, let's see. And yeah, looks like I see Fran, hopefully I'm pronouncing that right. Thanks for calling that out. The fact that last line in the Elixir function is a return value. It's good. Okay, let's keep rolling to destructuring. So in JavaScript, we're going to start with a const named O, and it's going to be a nested object. Nested would be the top level object at the key name, and then the value of that nested key is another object with prop as its key name and value of high. If we want to in our code only get to prop of that nested object, we can use destructuring like we have on the next line, where nested open curly prop close curly along with a default assignment of an empty object gives us prop, and then we can see in the comment high is the output of console.log. In Elixir, we have something similar, something akin to destructuring, but this actually has its roots in the match operator and in pattern matching, which we won't get into too deeply, but you're going to see it. You really can't avoid it when studying Elixir. You're going to see it, and it's akin to destructuring, but again, there's some very fundamental differences between the two. In this case, we have similar. O is a nested object. In this case, it would be a map in Elixir. Percentage sign curly is a map. Nested percentage sign curly prop with value of high. If we want to, again, extract the value of prop, we can do that with pattern matching. And the second line in this Elixir section shows us how to do that. We end up with prop as an attribute. If we call ioinspect, which is akin to console.log in JavaScript, io.inspect of prop is going to give us the value of high as a string. And again, pattern matching and match operator binding enables this syntax, which is quite different than what we see in destructuring in JavaScript, but it is worth comparing and contrasting the two. Okay, let's keep going here. So this is another example, a little bit of a more relatable example when talking about pattern matching, where we have a function named list, and that list is going to accept a user object, and that user might be an admin or just a general user. If it's an admin, then show me all of the elements in my store. If I'm not an admin, then I should only get a subset of those which I have permission to see. So that likely is familiar to you. If you spent time writing JavaScript. In Elixir, you'll notice that we can accomplish that same goal without any conditional statements. There's no if block. There's no switch statement, nothing like that. In this case, we have two functions, each with the same name. They're private, def p, so they're private functions. Each function is named list, and each function accepts one argument. So you would say, whatever the module name would be, my helper module dot list arity1 would refer to these two definitions. The difference, though, this is what is so powerful, is the argument you passed in is user. User is a map which has an isAdmin attribute on it, and the value of that may be true or may be false. So when I call my helper module.list with a user, it's going to match and execute this first list function if the user is an admin, has a value of true. If not, then it's going to use the second definition of list and simply give me a subset of all elements in my store. So this is, it's more declarative than having to use conditionals to work your way through certain business logic. This is a very common example, where you're looking for only things that a user has permission to see. It's a bit more declarative, where you can avoid those branching statements within a function and instead declare separate method definitions. Okay, so let's take a look then at control flow. I'm going to collapse the basic section. And we've seen a couple examples of control flow so far, but let's take a closer look at some other examples. And I've referenced switch case statements in JavaScript. In this case, we are making an HTTP request, most likely get a response. That response object has a status attribute on it, and we want to address two specific statuses on that response object, and then anything other than those two, we're going to return and consider it an error. So if response to status is 200, then it's successful. If it's a 401, that means the user is not allowed. If it's anything else, we didn't expect it, and there's an error. Okay, so this is a nice, concise way to write those different branches within your application and addressing different business concerns. What that looks like in Elixir, there's a couple more options than what JavaScript provides. In Elixir, we can use a case statement, we can use a conditional block, we can use with statement. Today we're going to look at case and conditional. And the case statement is quite similar to switch. I would say they're the most similar in that you take an object, a variable, in this case, get a response. Well, I suppose in this case it would actually be a function. So get a response would execute a function, and the return value of that function is going to be a tuple, either OK as the first element of that tuple, or error with a reason, or error with something unexpected. And so this case statement is very similar to switch in that you have one reference with multiple possible values, and depending on that value, you want to respond with success, not allowed, or an error statement. The one alternative way to use and to address different branching aspects of your code, of your business logic, is to use a condition. Condition doesn't require you to give it a value up front, so you could have what seem to be very disparate conditions in your flow, and you can address each of those distinctly with a condition block. So in this case, I've got three different very disparate comparisons to make, but they all work together, and I should only have one outcome based on the order of these conditions. So if I have a variable named foo and that equals the string of foo, I want to consider it a success. If that's not the case, then I want to look at the bar variable. If bar is less than 1, I want to consider it not allowed. And this little underscore down here is a catch-all. So anything else, I want to consider it an error. And so condition is, you don't often end up with very disparate comparisons to make, but it can be very helpful because it does occur where you have a system you're writing that has certain priorities. Step 1, if this is true, then do that. Step 2, if this is true, then do that. Everything else to do the other thing, and condition can be helpful to avoid writing multiple case statements. And let's see, we've also got an if-else block that you've likely used in JavaScript, where we can say if n is greater than 100, return 100. If it's anything else, if that's not true, then simply return n. And there's also the ternary operator, which says if n is greater than 100, question mark, return 100, else, colon, return n. Elixir also has conditional blocks where you've got an if-else, if n is greater than 100, do 100, else n, end. And so just a couple syntactic callouts to this. There are parens required in JavaScript. They're not required in Elixir, but you could use them if you had to manage operator precedent. You open up an if block with do and you end with end instead of the curlies that you are familiar with in JavaScript. There's also an unless statement, which reverses the business logic. JavaScript doesn't have unless, but it's convenient. And ternary, Elixir doesn't technically have a ternary function, but you can mimic it by doing a one-line if statement. So if n is greater than 100, comma, do colon 100, comma, else colon n. So it's very similar, but it's not quite the same as the syntax you're accustomed to when writing a ternary in JavaScript. And okay, let's see. Control flow. So there's an additional control structure in Elixir named the with block. It's very useful. There's not really anything in JavaScript that is comparable, so we left that out of this example, and it's a little bit more complex. But I just want to put a plug for the with block because it is very useful. And as you get to know some of the more similar case and conditional if else, you're likely going to want to dig into what the with block is all about. Okay, last section, we're going to look at list operations. So you've heard me say JavaScript array, Elixir list. They're very similar. They're the parallels to one another. When we want to work with a list, as we've seen already, that often we want to map, we want to filter, we want to do some transformation or extract some value from a list. And let's take a look at what it looks like in JavaScript when we want to map over a list. In this case, a very basic array of 1, 2, 3. What we want to do is we want to add a multiplier to each of those elements in the array to give us a new array named B. And in this case, let's map over array A, multiply each element by 2 in order to get a collection of elements with values 2, 4, and 6 named B. In Elixir, similar, we're going to have 2 lines in order to accomplish that. A is going to be bound to a list with values 1, 2, and 3. Using the enum.map function, we can take in A as the first argument to map. The second argument is an inline function, a stubby arrow function. That function takes one argument named n. We multiply n times 2 in order to get back a list with values 2, 4, and 6, and then we bind that list to variable named b. Okay, a couple more here. When we want to filter an array, there's a very similar pattern through each of these list operations. JavaScript here, we've got again the same array where we've got array of objects with attributes name and age, and we want to filter out people that are under the age of 22. And in this case, we're going to call the filter array function on our array named people. We are going to destructure our object. Well, it looks like we're actually missing some parens here around curly age, closed curly. We're going to destructure our object, extract the value of age, and then we're going to compare it to a value of 21, ending up with a single object in a list, in an array, excuse me, with Bob of age 30. In Elixir, similar, enum.filter gives us the same capability. We've got a list of maps, name Bob, age 30. We want to filter those out using an inline stubby arrow function, comparing age to 21, giving us a new list with only Bob of age 30 as the element within that list. Okay, and let's see here. We've got one more, which is reduce. So if you're new to reduce, reduce is not distinct to JavaScript or Elixir. It's as with any of these functions, they're obviously, there's equivalence across pretty much every language. Reduce is a concept, but often the function is going to be named accordingly in each language. In this case, it's the same in JavaScript and Elixir, where you've got an array that you want to do some transformation on. You might even end up with a completely different value. And in this case, we're not getting back an array. In this case, we're getting back a single value. So what we want to do is take an array 1, 2, and 3, and we want to reduce that down to the sum of its elements. So if you're familiar with reduce, this likely will come to you. If you're new to the concept, what happens with reduce is you take an accumulator. So you've got to start a starting place. In this case, our starting place is the number 0. That becomes our accumulator, and then the return function from each cycle through our list becomes the new accumulator value. And in this case, we're taking accumulator starting at 0, and we're adding n to it. So first cycle through, we'll get 1 as a return value. Second cycle through, we'll get 3 as a return value. Third cycle through, we'll get 6. And you can see the comment below saying sum is 6 after running that reduce function. Elixir's same thing essentially, and this is what the syntax looks like, where enum.reduce on a list of values 1, 2, and 3, starting with 0 as our accumulator, and then an inline function here with n and our accumulator as the parameters to that function, giving us, in the end, sum is 6. And that is the end of our examples. So, what kind of questions do you all have after that walkthrough? Happy to dig in and further explain any of this.
Awesome. This is great, Tim. Yeah, if anyone has any questions, feel free to throw it in the chat. If you have like a deeper question, it's hard to explain in the chat there, we actually can send you an invite to this call, and you could ask in real time, like on the phone basically, and we can walk through it together. So if anyone needs that, just let us know in the comments, and we can send you a link, and you can hop right in. So, but yeah, this is great. While we're waiting for any questions, Tim, what kind of resources do you recommend to folks to kind of get started with Elixir? And so, it's something that's more digestible instead of just going through. I mean, there is the documentation, but maybe if there's other resources out there.
Yeah, good question, Jacob. Thanks. Well, I don't want to recommend it if you need a different type of presentation, if your learning style is unique. But if you're willing to read, the written documentation in the Elixir community is fabulous. It's as good as I've seen in any language. You'll find examples, you'll find clarity, you'll find references to other elements within the language. You'll see tips, watch out for this or consider that. And so the Elixir language documentation is great. The language libraries within the Elixir community, you'll find in the documentation for those libraries, I should say, you'll find in HexDocs. And HexDocs, the community takes a good amount of care in crafting documentation for their libraries. So Elixir, the entry for a lot of people into the Elixir community is Phoenix. And the Phoenix framework is a very, very capable framework for you to write web applications. And the documentation for that is a great place to start. So getting to know the foundations of a language, which is what we tried to do today by comparing it to JavaScript, is excellent. If you're more if your learning style is different, where you'd rather start to build something and you want to learn it as you're building, I would recommend starting with Phoenix and creating an application locally and just working your way through the documentation on HexDocs or with the Phoenix framework website itself.
Awesome.
Yeah.
I dropped some links to the Elixir Lang documentation site and then the Phoenix framework as well.
Yeah, and I'd
Awesome.
say, Jacob, one more that's worth mentioning, Elixir School. There's plenty out there.
Oh yeah.
Elixir School is excellent. And one, again, I can't speak highly enough of the documentation in the community. What I found is there's not a lot of discrepancies when I go from resource to resource. In JavaScript, it can be difficult. In the JavaScript community, it moves so fast and things change so quickly that it can be difficult to find a level of confidence in the solution that you're reading about or the learning that you're gaining from another presenter.
Mm-hmm.
I've seen much greater level of consistency across the Elixir community when trying to understand and learn. So
all right. Well, awesome. We have a question from Josh. Since he helped us out before in the chat, we'll help him out. So he says, I find myself wanting to write if condition statements more than I should coming from JavaScript. Can you give me an example of when it would be correct to use a conditional statement versus pattern matching?
Ooh, that's a good question, Josh. Let's see. When would it be appropriate to do that? This might sound like a little bit of a cop-out, but some of that would depend on your team. Some of that is just preference. So as with any language, there's a couple different ways to accomplish the same outcome, and that's at the root of your question. I would say it can be a team preference. So you might take, an if-else. If this thing is true, do that, else do the other thing. You could write that as a multi-clause function, which those multi-clause functions are going to use pattern matching in order to accomplish their intention. One of the distinctions leading to your, let's see, one of the considerations leading to your decision would be team preference. You might also look at it and say, I can test these things separately. So I can write a unit test if I write a multi-clause function in a way that's a little bit more direct. The setup for that function might be a little bit easier to do than if you write a series of conditionals. You can also look at, well, if you're starting with if else, but you're anticipating if else, and then the other thing, as your application grows, you might also decide to do to leverage pattern matching with a multi-clause function. If you're sure it's going to be just either or, I would recommend just stay with what you're comfortable with and write your if statement, and then you can always refactor, right? Instead of spending too much time trying to decide what's the best, sometimes it's best to just get what you know and what you're confident in, and then come back and refactor as your application evolves.
Awesome. Thanks, Tim. Can jump over to this next one. Fran asks, could you talk a little bit of recursion?
Yeah, let's see, that's a big question. Frank, could you maybe be a little more specific about recursion? I don't know if you'd be willing to add in what context. I mean, Elixir as a functional language, recursion's very important to it. There's what's known as the cons operator in order to take a list and recurse over that, extracting head and tail, if you're familiar with that. Head would be the first element in the list, tail would be everything after it. How do I use recursion in my projects? Okay, so there's not often that I'm writing my own recursive functions in the web applications that we've written. Usually what we find is we're way more often using various list operations to work our way through and transform or extract values, but we're not often writing our own recursive functions. What the enum module provides, what the stream module provides, which is lazy enumerable, is it's a lot, it's very powerful, and so I don't often write a raw bit of recursive logic in my application. I'm usually able to leverage something that's already been provided. So yeah, Fran, I don't know that I have a good example because we just don't find ourselves having to do that very often. If there's a different, if you have a different example specifically, if there's a use case that you're questioning how you might solve, maybe I can help provide some suggestions as to how to solve it. But I don't myself have a real solid example that I could provide.
All right, thanks, Tim. Yeah, no worries. Fran, if you have a specific example beyond what you shared already, with more context, we'll do our best to answer it. We can jump to this next one. Sparky shares, you referenced Tuple before. I read the docs before this, and that was confusing to me. Can you explain how that plays in for Elixir?
Yeah, that's a good question. So tuple, T-U-P-L-E, I believe is what you're referring to. And if you could think about tuple as a fixed size list that can take various types of elements within it, and it's more restrictive than a list, quite a bit more restrictive than what you're familiar with possibly in JavaScript as an array. You can put any type of element, any number of elements into a JavaScript array. A tuple is fixed, so when you create a tuple, if it has 1, 2, 3, 100 elements, probably not going to do that. But if you had whatever number of elements in a tuple, it has to be it has to remain that way. You can't just continue to add to it or subtract from it. Now you can declare a different attribute which might represent a portion of your tuple, but you can't take that existing tuple and mutate it into something else of a different length. It's very useful. Probably the most common example of a use of a tuple would be an OK or an error tuple. So as you think about making an HTTP request, for example, one of these was actually in the Elixir for JS Dev site that I've been sharing. As you make an HTTP request, that either may have been successful or may have failed. The function that you might call to execute that HTTP request often is going to respond with an OK or an error tuple. And it makes it very easy for you then on the receiving end of that function call to look and say, it was okay, this was successful, and I want to look at the second element of my tuple to get the response from that HTTP request. Or it was an error tuple, I want to look at the second element of that tuple to get the error message or the error payload. So it's very descriptive. It's the object itself, the data type itself is useful in many ways. That's probably the most common example of its use. And yeah, I find it very helpful instead of maybe passing a string or some other approach, comparing numbers, as you may be familiar with in JavaScript when looking at HTTP status. So hopefully that helps, Sparky. So this would not work, for example, like a list. Correct. So you would, if you have a list, an unknown length of elements that you want to create an array of in JavaScript, you wouldn't use a tuple for that in Elixir. You would use a list for that in Elixir.
All right, awesome. We have this, I think this will be our last question. We'll wrap things up here just because we're running out of time. So thanks everybody for your patience today and all your questions. Alice asks, is there a framework like Express in JS or Flask in Python?
Yeah, so the Phoenix framework is the one, I mean, it's the most popular one. It's what has brought probably the most attention to the Elixir community. There's others as well. I haven't played with the others, so I can't really speak to them, but I suspect they're worth looking at. I know that if you use Phoenix, you'll be very, very pleased. It's fantastic, especially if you're familiar with Express or Flask or Rails. A lot of the inspiration that you'll see in Phoenix, and even some of the conventions in Elixir, you'll find had some origination in the Rails community. Yeah, so hopefully that helps. If you want to check out phoenixframework.org, that would be my best advice.
Awesome. Thanks, Tim. We'll wrap things up. I'm going to share my screen. Let's see here. Get my sharing things going. There we go. Just wanted to let everyone know we have some more events coming up on our YouTube channel here. You can also subscribe, or register, I should say, and get reminders on your calendar, all that kind of stuff on our website. So if you go to headway.io/events, you'll be able to see these. So we had our event today. Tomorrow we'll be talking with Chris Ewell, the co-founder and CEO of Kinetic, about how he kind of validated his idea and solution of building a new professional networking platform, which is pretty cool. We'll be talking about guiding design with product strategy next week with Katie from our design team. Kelsey will be talking about advanced TypeScript and some of the things you can explore to level up your TypeScript skills. So that'll be cool. And then next month, we're also talking with Teresa Torres about continuous discovery habits within product strategy. And then Billy will be wrapping up June about creating user flow diagrams from customer journey maps from a design perspective. So lots of stuff coming up. And then we're also hiring. So if you're a designer or developer and you're looking for a change in your career, or you're looking for a new opportunity, we're hiring product strategists, designers, different types of developers. So be sure to check those out, and we hope that you find something that you're looking for and to please apply. So that's it for today. Thank you, everyone. Again, as a reminder, this will be available on the YouTube channel after this. So if you want to rewatch it, and be sure to check out the link at the top of the chat. I pinned it as the resource for what Tim was sharing today. And yeah, we appreciate everyone taking the time to be with us today. So Tim, do you have anything else you want to share before we wrap things up and say goodbye?
No, just thanks, everybody. Again, appreciate your time and your questions. If you do visit elixirforjs.dev, there's a link at the bottom. Feel free to click submit issues through the GitHub repo, and we'd be happy to add more information, more detail to that site, so you can all continue to learn and benefit from it.
Awesome, cool. Yeah, I got it set up right here, so be sure to check it out. And everyone, take care and have a great day.